The good old classic Boss pedal. This is of course broken. This is of course phase shifter PH-3. Seemingly the impossible. It turned up on eBay quite cheap when usually Boss pedals get listed as an auction and get dived on by loads of people when they're broken. Not sure why specifically people jump on Boss pedals and pay lots of money for them when they're broken, but they do. But in this case, this turned up, buy it now, at a really good price. And unusually, it had got a photo of the actual burnt out component in the listing itself. This is a digital pedal. It uses a microcontroller, a DSP chip and a AD to DA conversion chip. Although of course this pedal has a 9-volt power supply, those digital chips and all that logic are powered by a 3.3 volt rail, and that's provided by a DC to DC buck converter chip. And that particular buck converter chip is very evidently blown. Now, as several of the Boss digital pedals are made in the same way with much the same hardware, not always identical, but in much the same support hardware at least, and it's merely the control interface and the software that's changed, of course, in the DSP stage and the microcontroller. The fault that this has doesn't seem uncommon in a range of other Boss pedals, and I haven't really seen anyone cover it specifically in much detail, in a video at least. So I thought I'd try and do that on this. It may be of use to someone. I don't know yet if I'm going to be able to sort this out, because there's every risk that this 3.3 volt chip has shorted out, booted 9 volts into all the logic and completely killed it. I don't know, but I'm going to find out. Naturally, I've already looked up circuit data and the part number for that particular chip, and it's one that's not impossible, but kind of difficult to get hold of at the moment, partly due, I think, to the component shortage. I think you can get them from America. I think Mauser supply them. So, of course, postage and whatnot, if you could find one, would be a lot of money. Maybe not if you want 1,000 of them, but it's just sort of one of those chips that's going to be awkward to get just for one simple cheap repair. So maybe jumping ahead of myself here, but what I'm going to attempt to do is generate a 3.3 volt voltage from an AMS 1117 module. I've got a bag full of them here. These are dirt cheap linear regulators. They're LDOs actually. Because I know the current draw on these is very, very low. So I'm going to take that dead chip out, we're going to probe around and see if there's any shorts or anything, and see if we can generate 3.3 volts from one of the 1117s to possibly get it going again. And there may be room inside this to put one of these little modules and continue to run it from there. So let's take it apart and see what we can find out. I've already checked to see that there isn't a battery underneath the top cover, and there isn't, so I'm going to go straight in and see what we have here. If you ever take one of these apart, don't forget the plastic insulator, otherwise you risk shorting out the traces on the back, especially around the power connector to the grounding plate on the back. You very carefully pull that forward. A ribbon cable and wiring from the jacks, so have to be very careful with our pull on that. And down here, if you can see, is where the blown buck converter chip is. Just to point out so I don't mix these up, with the battery knob at the bottom of the shot there, the grey wire goes to the bottom jack, the brown wire just there goes to the top jack. Hopefully that gives you a better look at the board. Of course all the jacks and everything are just sort of loosely on top at the moment. I don't think you can really completely get this clear of the case unless you undo or the button for the foot switch and the board with the controls on the top, but this will do us for now. In this section, of course you can see the blown chip there. We have a couple of inductors, one for input, one for output. This chip, because it's only such low current capability, uses an external MOSFET to do the switching, which is this chip just here. We have a 100 microfarad capacitor on the input and a 100 microfarad capacitor on the output. There's also the diode there on the output that keeps the output inductor positively charged, and there's a very tiny capacitor somewhere, it might be that one, which just sits across the output just to remove any fine noise. The main chips that you can see here are the DSP. This is made by Toshiba, I believe, and it's a standard sort of gate array that Roland can program. The microcontroller here, which I believe is made by Panasonic. Again, they will be able to program that. And then this tiny little ADDA converter for the audio, which I think might have, look closely, has actually got a tiny little Philips badge on there now, of course NXP. Also lurking under there, I think there's an op-amp chip, but that's the basics of it. So this section is what we're interested in, and handily there's these little tabs here that connect to the case for the grounding. So I'll be able to clip a ground lead to there and then go around and do some measurements and check for any shorts or anything, I think, around the 3.3 and 9 volt line. The slight problem is I have a very clear, well, a full PDF of I think the flanger pedal, which uses more or less the same thing, but it's not exactly identical. And the only actual circuit I've got of this is a horrible quality JPEG image. But I can just about read it. So between the two, even though some of the actual component references change numbers, between the two I can work out, without too much difficulty, what's going on. So it's a pretty straightforward buck converter circuit. Okay, without rearranging this completely, I'm kind of at the limit of how close and how far zoomed in I can get my camera. But I've cleaned up with some isopropyl alcohol, the blown regulator chip there, just to try and get a cleaner look at the tracks around it and where I can get in for probing it for shorts. I had to use my loop and an LED torch to really get in there. There are definitely some shorts. I have the ground connected to the tab in the corner of the board, and if I can get in here, there's a short between, there's your ground pin, that should be the on-off pin, which should actually be tied to the 9 volts high, so there is definitely a short. It could be caused by the chip, it could be caused by this tiny ceramic capacitor here. It could also be caused by this electrolytic capacitor here. So we've definitely got shorts in this area. So I think by this point I need to get this chip off. I think there is some trace damage. I think it's vaporized one of the traces underneath, so even if you were to replace it with a like-for-like chip, you'd have to do some board repair. But I'm going to take that off and check for shorts again. If I've still got shorts, I'm going to move on and see if perhaps we've got an issue with one of these ceramic capacitors. Again, I've read that it's not uncommon to find ceramic capacitor shorts in some of these Boss pedals, so I don't know if they had bad batches or what, but that's the first time I've ever seen a ceramic capacitor short, if that's the case. Alright, I think that's about the best I can really get the tape and everything around it. Gone for the finest point on my hot air station, so this will be interesting because there's a good chance, I'm going to have to try and hold this straight, there's a good chance the leg of that chip has bonded, welded itself really to the board. I've had this before, that happened with that Digitech repair, that fuzz pedal, or Dodd as it was. It's coming. This capacitor's come off. Let's have a look at this. Going great. I'm going to have to do this without the tape. It is loose, it's definitely loose. Yeah, there's definitely some welding to tracks there. I think it's going to have to be cut. Let's see what's going on there. So I'm also melting the cutting mat. Yeah. So what's happened there is, apart from melting my cutting mat, I really should have put something under that was stupid. You can see by the buckles in the board how much I've had to heat that, and it's actually welded itself to the traces. We have freed one trace there, but it looks like it may be the input pin, which has completely blown off. So I think we're going to have to look at this very closely. Okay, update. I've removed the offending chip. You can see the board looks a real mess there, and that's entirely my fault. So does my cutting mat. That's also entirely my fault. I've had this in the past. When you try and remove a component with hot air that has exploded, basically, it's not uncommon for the pins of the component to actually weld themselves to the copper traces, not just solder, but actually weld themselves to the copper traces. So heating them to a temperature with the hot air, which would normally melt the solder and of course free the component, it did free it on a couple of the traces that are okay. But I do think we've had some kind of short on the input pin, because the damage around there to the trace, I mean, it's completely torn, it's completely vaporized, and the short has now cleared. I did notice by measuring across the power jack before, I think I was getting something like 600 ohms between ground and positive, and I now get it's completely open on my meter. In fact, if I do measure the impedance, yeah, there's what are we getting there? About 10 megohms. So there was, of course, an issue there, and that's short across the this capacitor, if there's anything left of it. There's the ground side, and that's the side that was shorted out, which now seems fine. Same there, there's the negative ground side, and I have nothing across the positive. Might have to, obviously I've got to put this one back on, but I get about 600 ohms across that, and of course that's the ground side, and the other side's wide open, I guess, because it would have been connected to this, so it's at least cleared that short there. I've managed to take some close-up pictures with my phone and with this loop lens to try and work out exactly what's gone on here. The main trace that's got damaged is there's a link between pins 1 and 5, which basically ties the on-off control of the chip high on the input side, and it's that link that's gone between 1 and 5, pin 5 mainly, where the trace has just been vaporized. So it's really strange. It's as if there's been a short somewhere that's pulled that down to ground, while of course it's been pulled up, and just obliterated it. The actual output side, or should I say V out, which is a voltage monitoring pin for the output, and the external pin which drives the switching to the MOSFET, are all okay, and the ground pin did also get welded on, but I managed to cut it off, and there is a trace of it there, and it's still connected, it's okay. And the other pin here, which looking on there would have been the input pin, pin 5, is actually still in that bottom corner, but it's just a trace that goes across to what would have been pin 1, the on-off pin, in this top corner here, which has just been obliterated. So it's really really bizarre. I think the next step will have to be to remove this MOSFET, because I'm concerned that with nothing on the bottom of that it might just short straight out, so I think I need to break the connection by removing that MOSFET. Slight change of plan. You might notice I've actually cleared most of that area. The reason is, what I'm actually going to use, if this is going to work for the 3.3 volt supply, is one of these tiny little modules which has got components on the back and then the actual regulator, 1117 on the front. And if I can get this to work, there's a chance I can tap into the ground and the 3.3 line where that C51 was, and it can possibly, if I insulate the board, I might have to clear the solder pads, insulate the board, it may just fit. But we'll try it with some wires first. Just as a quick test, I've plugged this battery clip into the DC jack and put a plug in the guitar input jack, just to switch the contacts to turn it on. And if I apply 9 volts to it, it's drawing 10 milliamps, and there's a brief flash of 20 milliamps when it first powers up. So I know that at least the op-amp rail, and I believe in this one there's a 9 volt input to the microcontroller that's something to do with the control pots. So I know it's drawing some current and there isn't a short on that side. So I think next thing is to try and find that 9 volt output here, and then wire it into one of the little regulator chips, and then see if we can measure the current being drawn at 3.3 volts if we bring up the voltage slowly and current limit the power supply. Okay, there's a little bit of clip lead spaghetti going on here, so this is slightly awkward to get around, but at the positive end of where C43 was, that should show input voltage, and if I flick the power supply on, it does, we get 8.6. There's a little bit of drop through the resistance in that inductor, which is still there, so that's fine, but that's our source voltage for where the 1117 is going to be fed. This is a very rough lash up, but just to prove it works, I've soldered the 8.6 volts that we were seeing from that capacitor and the ground just to the little regulator module there, and the 3.3 volt coming off it is not connected to anything, it's just going into the meter, just to prove that the regulator is running. There's our 3.3 volt output. A little bit more added to the clip lead spaghetti. Here's our 3.3 volt output from the regulator, here's our 3.3 volt input to the board. This is going to measure the current that's being drawn on the 3.3 volt rail. I'm going to turn it on. 65 milliamps. And we're drawing 70 milliamps total on the 9 volt side. Now 80 milliamps, that's just jumped up. Let's see. Pressing the pedal, I don't see any activity on the light. Just turn that off, anything warm. The regulator doesn't feel warm. The only light that's coming on there is there's a little light on the back of the regulator board. You may just be able to see. But something is drawing current there. So I may put this on a scope around some of the digital side to see if we have any data and clock. Okay, so in the last segment I think we've pretty much ascertained that this pedal is dead, and I've actually got the scope on, and I'm going to go through some of the digital logic just to show a couple of things that I found that I think have pretty much put the final nail in the coffin for this. I think the damage that the regulator failure has caused has been done to some of the logic with the DSP and the CPU, because let me just show you there. If we look at put the power on, it might help. If we look at the main crystal, we see we've got our 33 megahertz main output, so the main crystal is running. The main crystal feeds the DSP chip, and then the DSP chip divides down two further outputs. One goes to the CPU and one goes to the ADDA converter. There are two reset generators, these tiny little chips here. There are two because the reset timings of the DSP and CPU have to be slightly different. The DSP has to be the first to reset, and then the CPU follows it. I actually had to do a two-channel trigger to try and find out that this was working properly, that both reset generators actually had a delay and that the delays were roughly correct. I'll put up a couple of pictures to show you the results that I got. I had to do that with the scope in single trigger mode, just to check that the reset generators were working with a sufficient delay, because it's so fast it's impossible to just see it without. So we don't have a reset problem, but here is the problem we do have. Coming out of pin 42, I believe it is, on the DSP, and going into pin 15, I think it is, yes, on the CPU. I'm reading a circuit diagram that's very blurry, unfortunately. But in pin 15, which is there, we should have a clock, and we don't. We have nothing at all. That pin is unfortunately completely dead. So with no clock going to the CPU, of course it's not doing anything, which explains the latch-up condition, explains the current being a bit higher than it should be, and explains that it's just not doing anything, because it literally is not doing anything. But interestingly, looking at the clocks around the ADDA converter, if we look at pin 12 on that Philips chip, so we've got 5, 10, 11, 12, pin 12 will be down there. We can see we've actually got an 11 megahertz clock there. That's the system clock for the converter. So the converter does have some clocks, but the main CPU unfortunately does not. There's a couple of other pins now, bear with me because these numbers are so blurry on the only copy of this circuit diagram that I've got. We've also a bit clock on, I believe, pin 16, 14, 15, 16, so that would be around here. We've got something there, what's that? Interesting, so we have a bit clock at 2.8 megahertz. So yeah, that's really strange that we have, the bit clock comes from the DSP. So we've got almost all of the clocks from the DSP, but not from the CPU. Now that could be because either the DSP output on that clock line is faulty, or it could be that the CPU is pulling it down. That is interesting that the couple are connected to the ADDA converter work. The ones around the CPU don't. Unfortunately, there's nothing else on that line that could pull it down or anything like that. It's just a link that goes from one to the other. Even if I check its direct output at the DSP itself, which is pin, I think it's pin 42. It's pin 42, so that would be pin 40, 41, 42. Be next to that one there, that would be pin 42. You see it's just dead. So it could be a blown CPU that's pulling it down, and unfortunately, unless you got one of these identical pedals and took the chip off it, there's no chance of getting that chip, because it's mask ROM'd likely specifically for this pedal. So without a CPU clock, there's nothing we can really do. We could break the main clock out, maybe divide it down externally and try it, but if there's further faults with the CPU, I don't think injecting a clock like that is going to work. I think it's just going to pull it down exactly the same as it's already doing. So I suspect the DSP is probably okay, the converter is probably okay, but there's something wrong with the CPU that's I think been caused by that 3.3 volt rail failure. So unfortunately this is going to be spares and scrap. It does happen, as I've said before, you don't win them all. It was an experimental repair, but there might be something in this that may be useful to someone else that wants to have a look at this. So if you want to find your way around any of the digital logic in a Boss pedal, or if you manage to swap the regulator and it brings your pedal back to life, that's great. The current draw I think should be about half of what we've got here. This regulator's running, yeah, it's running a bit warm, and it shouldn't really be. There isn't a lot of mass on that board, of course, for so turn that off, for heat dissipation, so you can't really run these up to the recommended maximum of the actual chip itself. They'll do maybe 50 milliamps comfortably inside something, you know, but they will run warm if you try to draw nearer to 100. So we definitely got a latch-up condition, I think, in that CPU. If for any reason I came across a CPU out of one of these and I was able to swap it, I'd get the hot air out and do it. But yeah, we're not likely to find one of those, unfortunately. So I think it's end of the line for this particular pedal. But maybe there was something in that of use to you, or of entertainment, whatever. But either way, thank you for watching.